we are on to now is number basis. Number basis has been a topic you must have had in your junior classes. So I want to use this opportunity or seize this opportunity to get you equipped with what the external examination bodies require of you, or maybe the manner they actually want you to understand this topic, and for you to be focused on the way your understanding about it should be, so that you'll be able to tackle examinations. Otherwise, this topic is supposed to be the topic for SS1 and SS2. So now, the first question we have there says, what is the place value of 3 in 312 if 312 is in base A 10, B 8, C 5? It can be 6, it can be 7, it can be 9, it can be 2, it can be 3. So I will use these 3 examples to tell you how to find the place values of digits in bases of 10 and bases that are not 10. First of all, let's take the first question. Question number A. We have 3, 1, 2. 3, 1, 2 in base 10. 3 is going to be, if you write the 3 out, you multiply it by, since it is base 10, you multiply it by 10 in the number of the remaining digits that are left after you have picked the number you want to find its place value. What I mean is that you're going to multiply 3 by 10 because of 1, and multiply it again by 10 because of 2. When you solve this, it will give you the place value of 3 in 312 in base 10. 10 times 10 will give you 100, times 3 will give you 300. That means the place value of 3 in 312 is 300. For instance, had it been that this question says, what is the place value of 1 in 312? It could have been 1 times 10 because of the remaining digits after you have picked the number. The 1 by the left hand side is not a party in finding the place value. So it could have been 10. Had it been the same 2, it could have been 2 times 1, because there is nothing left after 2. So it could have been 2. It is in that order. So question number B says the place value of 3 in 312 if 312 is in base 8. Just like in base 10, you have 3, 1, 2. You are looking for the place value of 3. So bring out the 3 and begin to multiply. Now by 8. You multiply by 8 because of the next digit after the one you're finding its place value. And multiply it again by the same 8 because of the next digit. That is how to find it. So you're going to have 8 times 8 will give you 64. Now 64 times 3. 192. That means the place value of 3 in 312 base 8 is 192. Likewise, and if they say the place value of 1, you know it's going to be 1 times, because of the next digit 8, which will give you 8. Is in that procedure. So whatever base, use that base to keep multiplying what you are finding its place value by the number of digits that are left after that number. So question number C is synonymous, base 5. So we have 3, 1, 2, and we're looking for the place value of 3 in base 5. That means this is in base 5. Multiply by 5 because of 1, multiply by 5 again because of the second digit 2. So we are going to have 25, that is 5 times 5, 25 times 3, which is 75. That is the place value of 3 in 312 base 5. In descending order. That means we have to know the values of all this number, then arrange it in descending order. Means the greatest first, followed by the next one, and the least one. Alright, if you are given something like this, the first thing you do is try to convert the whole of the numbers in their different bases, convert all of them to base 10. That is when you will not know what values they have. And converting numbers in different bases to base 10 in their bases, bases, and adding them up. So the first number is 41 base 5. 41 base 5 means 4 times 5 raised to power 1, that is remaining, plus 1 now times 5 raised to power 0. 4 times, first of all, 5 raised to power 1 or 5 exponent 1 means 5. Then 5 times 4 is 20. Anything exponent 0 is 1. That means 1 times 1 will give you 1. We have 20 here. 20 plus 1 will give you 21. So we have that 41 base 5 is having the same value as 21 base 10, but you don't write 10 below like this. Whenever you see a number without a base written below it, it means base 10. So this is the value of 41 base 5 in base 10. Let's take the next one. The next one is 10111 base 2. Take the first 1 times its base 2 raised to power the remaining digits 1, 2, 3, 4 plus 0 times 2 raised to power the remaining digits 1, 2, 3 plus 1 times its base raised to power the remaining digits 1, 2 plus 1 times 2 its base raised to power the remaining digits, which is 1, then plus 1 times 2 raised to the power of no digits remaining. 0 means no digits remaining. This is 1 times 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That means 2 exponent 4 means 16. So we have 1 times 16 here. Thus, this is 0 times 2 times 2 is 4. 4 times 2 is 8. That means 2 exponent 3 means 8. Plus 1 times 2 squared means 2 2 times 2. That means that will give you 4. So we have 4 here, plus 1 times 2 exponent 1 means 2. So we have 2 plus 1 times anything exponent 0 is 1, including u. U exponent 0 is 1. So we have 1 times 1. So let's simplify. 1 times 16 will give you 16. Plus 0 times 8 will give you 0. Plus 1 times 4 will give you 4. Plus 1 times 2 will give you 2. Plus 1 times 1 will give you 1. Now the next thing we do now is to add. 16 plus 0 is 16. Plus 4 is 20. Plus 2 is 22. Plus 1 is 23. So that means the value we have here is 23 base 10. But you don't write the base 10. As long as there is nothing written on it, that means it is in base 10. Now let's take the next. The next is 26. 26 base 8. So 26 base 8 has the value in base 10 in this order. Take the first digit 2, multiply it to the base 8, and raise it to the value of the remaining digits, which is only 1. Add it to take the next digit 6, multiply it to the base of 8, and raise it to the value of the remaining digits. But there's no digits remaining. That means you raise it to power 0. 8 exponent 1 means 8. So 8 times 2 will give you 16. Plus anything exponent 0 is 1. That means 8 exponent 0 is 1 times 6 will give you 6. Now we are going to have that 16 plus 6 will give us 22. So we have 22 base 10 being the value of 26 base 8. The last among them is 110 base 4. Its value in base 10 takes this form. The first digit is 1, multiply it by the base, which is 4, and raise it to the value of the remaining digits, which is 1, 2. Plus 1 times base 4 raised to power of the remaining digits, which is 1. Plus 0 times the base 4 raised to the power of the remaining digits, which is 0. 4 squared means 4 times 4, and 4 times 4 is 16. That means 16 times 1 will give you 16. Plus 4 exponent 1 means 4. Then 4 times 1 will give you 4. Plus anything exponent 0 is 1. Then 1 times 0 will give you 0. So add 16 plus 4 will give you 20 at the dot. That means 110 base 4 has the same value of 20 base 10. Now we have found the values of all those numbers. The first one is 21, next is 23, the other one is 22, and the last is 20. Now let's go to the question. The question says we should arrange them in descending order. The greatest first, the next to it, the next to it, and the least. So if you look at this value now, you discover that 23 is the greatest, and 23 base 10 is 10111 base 2. So pick 10111 base 2. 10111 base 2 is the greatest. The next after 23 should be 22. And the value that gave us 22 base 10 is 26 base 8. So take 26 base 8. After 22, the next in value is 21. And it was 41 base 5 that gave us 21 base 10. So take 41 41 base 5. Then the last is now 20, and it was 110 base 4 that gave us. So have 110 base 4. So this is the order of the arrangement in descending order. And that has brought us to the end of question number 2. Question number 3 says, assuming 25 base x is equal to 32 base 5. Find x. If you have this kind of question, what to do is, this number that its base is given, convert it to base 10. So let's convert 32 base 5 to base 10 by expanding and adding. So we have 3 times 5 exponent 1 plus 2 times 5 exponent 0. 5 exponent 1 is 5 times 3 will give you 15 plus 5 exponent 0 is 1 times 2 will give you 2. 15 plus 2 will give you 17. That means 32 base 5 is 17 base 10. Now pick the other number that its base is not given. Expand it with the unknown base and equate it to 17. What I mean is, bring 25 base x and expand it. It's going to give you 2 times x, because the base is x, exponent 1 plus the next digit 5 times its base x, exponent 0. So this is going to give you x exponent 1 is x, and x times 2 will give you 2x plus x exponent 0 is 1. Anything exponent 0 is 1. Even your grandmother's cooking pot, exponent 0, it will reduce that pot, no matter how big, no matter how small, to 1. Alright, so 1 times 5 will give you 5. Now, this 2x plus 5 is the value of 25 base x in base 10. And already you have converted this number to base 10. That means equate this and this, because the equation says that this is equal to this. So we are going to have 2x plus 5. 2x plus 5 is equal to the value of 32 base 5, which is 17 in base 10. If you simplify this, you can find x. Subtract 5 from both sides. That means on the left hand side we will be left with 2x, and it's going to give you 17 minus 5. So you're going to have that 2x is equal to, if you subtract 5 from 17, you have 12 left. So you're going to have 12. Divide both sides by 2. If you do so, you are eliminating 2 as the coefficient of x in the left hand side of the equation. You'll be left with only x on the left hand side of the equation. And on the right hand side, you're going to have 12 divided by 2. And 12 divided by 2 is 6. That means x has the value 6. That equation will now be that 25 base 6. Sorry. 25 base 6 is equal to 32 base 5. I want us to think, if this is exactly this, this is not part of the equation. The equation has ended here, that x is equal to 6. But I want to check. Expand this in the power of its base and see if it will be equivalent to expanding this in the power of its base. But we have expanded this in the power of its base to get 17. So let's expand this in the power of base 6 to see if we get the same 17. So So we have 25 base 6 is going to be 2 times 6, the base, exponent 1, plus 5 times 6, the base, exponent 0. 6 exponent 1 is 6 times 2 will give you 12, plus 1, then 1, then 1 times 5 will give you 5. You can see that 12 plus 5 is 17. That means you were correct. Remember, we just checked here. This is not part of the question, but you can do this kind of a thing on a rough paper outside your examination answer sheet to check if what you calculated for the value of x is correct. Question number 4. Question number 4 says you should find the value of 1 in base 10 of 100 base 2. There is to be confusion to students about finding the place value of a particular digit and finding the value of a particular digit. The ones we did previously in our previous questions, question number 1 and 2. The question says you should find the place value. In that case, you don't need to convert the given number to base 10. Just begin to multiply in progression with the base. Then you will get the value, the place value of whatever you are asked for. But in this case, the way you go about this, finding the value of a particular digit in a particular base, is convert it to base 10. Try to expand. Go into the process of converting the base whatever to base 10. From there, I will show you how you find the value that the question is asking for. Just as you have 100 base 2. If you have to expand this, go into the process of converting it to base 10. You're going to have the 4-digit 1 times its base exponent, the remaining 2 digits, plus the next one is 0 times its base 2 exponent, the remaining digits, which is 10, plus the next digit 0 times its base exponent, the remaining digits, but there's no digits left, so it's going to be 0. Now expand or simplify. 2 squared is 4. So I'm going to have 4 times 1 is 4. Plus 0 times, you know that 2 exponent 1 is 2. Times 0 is 0. Plus 2 exponent 0 is 1. Times 0 is 0. Now, you can find out that the one that the question is asking for its value is this first one, and it is in this place. So the value of 1 in base 10 of 100 base 2 is equal to this number, which is 4. So that is how to answer this type of question. All adventure it confronts you. I would like to use this question number 5 to add more light to you on the difference between finding the place value of a digit and finding the value of the digit. So if you're asked to find the value of 1 in base 10 of 214 base 5, get into the process of expanding this as if you want to convert it to base 10. So we're going to have that 214 base 5 is equal to 2, the first digit, times the base, which is 5, exponent, the remaining 2 digits, plus the next digit, which is 1, times its base, which is 5, exponent, the remaining digit, which is 4, plus the last digit, which is 4, times its base, exponent if there's any other digit, but there's none, so it will be exponent none. None means 0. 5 exponent 2 means 5 times 5, and it will give you 25. 25 times 2 will give you 50. Plus 5 exponent 1 is 5 times 1 will give you 5. Plus 5 exponent 0 is 1 times 4 will give you 4. Now the one the question is asking for its value falls in here. So whatever you get by simplifying what you have in between these two signs of addition, which is 5, is the value of 1 in base 10 of 214 base 5. So that value of 1 the question is asking for is this, which is 5. Had it been that the question asks for the value of 2, it could have given you 50. Had it been asked for the value of 4, it could have given you 4. Question number 6 says we should convert 11011 base 2 to base 10. Expand it in the power of its base and do the addition of the result of the expansion. Whatever you get is in base 10. So we have 11011 base 2. It's going to give us, pick the 4 digits, 1, multiply by the base 2, put it to the exponent of the remaining digits, 1, 2, 3, 4. So we have 4. Plus, take the next digits, 1, multiply it to the base 2, put it to the exponent of the remaining digits, 1, 2, 3. Plus, take the next digits, 0, multiply it to the base, which is 2, put it to the exponent of the next remaining digits. All this number will be increasing until the last one that is going to be 0. Plus, take the next digits, which is 1, times the base 2, exponent 1, plus the last but not the least, 1, times the base 2, exponent 0. Now simplify. 2 exponent 4 means 2 times 2, 4 times 2, 8 times 2, 16. So 16 times 1 will give you 16. Plus, this means 8. 2 exponent 3 is 8. It means 2 times 2, 4 times 2, 8. Then 8 times 1 is 8. Plus, 2 exponent 2 means 2 times 2, which is 4. 4 times 0 will give you 0. Plus, 2 exponent 1 means 2. 2 times 1 will give you 2. Plus, 2 exponent 0 is 1. 1 times 1 is 1. Now, if you add, whatever you get is the value of 11011 base 2 in base 10. Let's add. This plus this is 10. 10 plus 16 is 26, plus 1 is 27. So we have 27 base 10 to be the value of 11011 base 2. This is question number 7. And the question said we should convert 136 base 8 to base 10. Just like the previous question number 6. Begin to expand this. We'll have 136 base 8. Converting it to base 10, we take this procedure. Take the 4 digits, which is 1, multiply by the base, which is 8. Put it to the exponent of the remaining digits, 1, 2. Plus, the next is 3, times the base, which is 8. Put it to the exponent of the next remaining digit, which is 1. Plus, the next is 6. Multiply to the base, which is 8. Put it to the exponent of the next digits, but there's no digit, that's why you put 0. 8 squared means 8 times 8. 8 times 8 is 64. 64 times 1 will give you 64. Plus 8 exponent 1 means 8. 8 times 3 will give you 24. So what we have here is 24 plus 8 exponent 0 is 1. That means 1 times 6 will give you 6. If you add these values together, whatever it gives you is the value of 136 base 8 in base 10. 6 plus 24 will give you 30. 30 plus 64 will give you 94. So we have 94 base 10 to be the value of 163 base 8 in base 10. In all our past practices, we have been converting from other bases to base 10. Now I want us to commence converting from base 10 to other bases. And the first question we start with is question number 8, which says that we should convert 62 base 10 to base 7. If you are given a number in base 10 to convert to any base, begin to divide that number in base 10 by the new base you want to convert it to, progressively the way I'm going to illustrate to you now. Write down the number in base 10, 62. Draw a line. Write the base you want to divide with, or you want to convert it to. 7 divides 62, sorry. 7 times 7 is 49. 7 times 8 will give you 56. 7 times 9 will give you 73. So what you have is 8. And what is remaining? Whatever that is remaining, add it plus and keep it here. 7 is 49. 7 is 56. So if you subtract 56 from 62, this will give you 6. So 6 is remaining. So write the 6 that remaining as plus the 8 that you could get 7 inside 62. Come again to that level, divide with 7. 7 divided 8 will give you 1, and 1 is remaining. Write the remaining 1 here. Some students will stop here. They will say there is no 7 inside 1. Yes, there is no 7 inside 1, but you still have to divide more, the way I'm going to explain now. Divide by 7. There is no 7 inside 1. That means there is no 7 inside 1. Then bring down the 1. Now pick this value 611 as 116. Pick the value in this order. So it's going to give you 116 base 7. That means 62 base 10 is having the value of 116 base 7. Question number 9 says we should convert 312 base 4 to base 7. There is no direct link in O-level to convert bases from bases that are not 10 to other bases that is not 10. So the first thing you do in this concept is, first of all, convert this number to base 10. When you have converted it to base 10, so the value you get in base 10, then convert it to base 7. So first of all, we are going to convert this to base 10. So we have 3, 1, 2 base 4. Converting it to base 10 takes this process. 3 times 4 exponent 1, 2 plus 1 times 4 exponent 1 plus 2 times 4 exponent 0. 4 exponent 2 is 4 times 4, which is 16. Now 16 times 3. 16 times 3 is 48. So we have 48 here plus 4 exponent 1 is 4 times 1 will give you 4 plus 4 exponent 0 is 1 times 2 is giving you 2. So we have 2 plus 4, 6. 6 plus 48, 54. So what you have here is 54 in base 10. Now convert this 54 base 10 to base 7 by the progressive division. So we have 54, begin to divide progressively by 7. 7 into 54. 7 times 7 is 49. So if you remove 49 from 54, there is no other 7 left. So we have 7 pieces plus 54 minus 49 is going to give you 5. So write plus 5. 7 divided 7 is 1. Nothing is remaining. So write plus nothing is remaining. 7 divides 1 is not possible. Then bring down the 1. So take your value in this order. Not 501 but 105. So that means 105 base 7 is the value of 312 base 4. Question number 10 says we should convert 1111 base 2 to base 4. First of all, convert this to base 10 and now reconvert it to base 4. So we have 1111 base 2. Let's convert it to base 10. 1 times the base 2 exponent 1, 2, 3 digits left plus the next 1 times 2 exponent 2, the remaining 2 digits plus 1 times 2 exponent 1, the remaining 1 digit plus 1 times 2 exponent 0. So now let's multiply out. 2 exponent 3 means 8. 2 times 2, 4. 4 times 2, 8. So 8 times 1 will give you 8. Plus 2 squared is 4. 4 times 1 is 4. Plus 2 exponent 1 is 2. 2 times 1 will give you 2. Plus 2 exponent 0 is 1. 1 times 1 is 1. So we have 3 plus 4, 7. 7 plus 8, 15. So that means the value of this is 15 base 10. Now we are to convert 15 now back to base 4 by progressively dividing by 4. So we're going to have 15 and we're going to divide it progressively by 4 because we want to convert 15 in base 10 to base 4. 4 divides 15. There are 3 4 inside 15. And that 3 pieces of 4 is 12. If you subtract 12 from 15, you have 3 left. So you have plus 3. 4 divides this, cannot, you have 0 plus 3. So we are going to take your values in this form. It's going to give you 33 base 4. And that has brought us to the end of that question number 10.